The exhaust system of the direct injection petrol engine 2 also displays some special characteristics which are due to its particular design. The first section of this chapter presents you with an overview of this system. You will then learn about measuring the residual oxygen content, which requires the use of a new type of oxygen sensor. The chapter concludes with a look at the nitrogen oxide or NOx storage catalytic converter, which, as the name suggests, both stores nitrogen oxide and also converts it by means of a catalytic process. Let's take a look now at the exhaust system of the direct injection petrol engine shown here. The exhaust system consists of the exhaust manifold, the oxygen sensor upstream from the catalytic converter, which relays the control signal for the lambda control, the three-way catalytic converter, and the oxygen sensor downstream from the catalytic converter, which monitors how effectively the catalytic converter is working during homogeneous engine operation. So far, the exhaust system is identical to that fitted to a manifold injection engine. Now it's time to look at the differences. The exhaust tract divides up into one thin exhaust pipe and one thick, longer exhaust pipe. The control system can shut off or open this second pipe with the aid of the exhaust flap. Both pipes lead to the NOx storage catalytic converter, where a temperature sensor measures the temperature of the exhaust gas flowing into the storage catalytic converter, and a nitrogen oxide sensor measures the amount of nitrogen oxide flowing out of the storage catalytic converter. The rear silencer design on the M271 series is basically the same for all manifold injection and direct injection engines alike. The precise shape, on the other hand, varies to suit the different chassis and bodywork designs. The exhaust system of the M271DE is fitted with 4 sensors. Where exactly are these sensors located? Watch now as the labels are placed in the correct positions. The first oxygen sensor is located upstream from the three-way catalytic converter, and the second sensor downstream. The temperature sensor can be found at the input of the NOx storage catalytic converter, while the nitrogen oxide sensor is located at the output. The oxygen sensor upstream from the catalytic converter is a special broadband sensor. First, though, let's take a look at the conventional 2-point oxygen sensor, which is also known as a lambda probe. The output voltage of the probe suddenly changes at a lambda value of around 1. Now do the same for lambda 1.01. Do you see what happened? Although the lambda value only increased by 1%, there was a large drop in the probe's voltage. This, of course, allows precision adjustment to lambda 1. The lean mixtures used for direct petrol injection behave quite differently from lambda 1 mixtures, however. Compare the different readings. As you will see, although there has been a significant change in the lambda value, the voltage in the sensor only dropped by a couple of millivolts, which can easily disappear in the background interference signals. This means that the 2-point oxygen sensor, in other words, the conventional lambda probe, is not suitable for measuring the residual oxygen content of a lean mixture. A special broadband oxygen sensor is needed to measure the residual oxygen content of the exhaust gas. It works based on a different principle, producing therefore a completely different chart line too. At lambda 1, the sensor's current output is 0. A leaner mixture produces a continuous increase in current output. Using this type of sensor, it's possible to measure the residual oxygen content in lean mixtures too. Note also that the chart extends over a far broader lambda range than in the case of the 2-point oxygen sensor. As already mentioned, the oxygen sensor upstream of the three-way catalytic converter measures the residual oxygen content across a broad lambda range, while the oxygen sensor located downstream only measures the efficiency of the catalytic converter in homogeneous mode, when the lambda value equals 1. The broadband oxygen sensor measures the residual oxygen content in the exhaust gas from the engine. The 2-point oxygen sensor checks the efficiency of the 3-way catalytic converter in homogeneous mode. The pollutant levels produced by petrol engines are particularly low at lambda 1. At this value, fuel and the oxygen contained in the intake air combine completely. This is what happens when direct injection engines are operating in homogeneous mode. However, as soon as the engine enters the economical stratified-charge mode, there is permanent surplus air. This means that there is still unburned oxygen after the fuel has burned. What essentially happens next is that the hot flame causes the surplus oxygen to react with the nitrogen in the intake air, resulting in the formation of nitrogen oxides. As nitrogen oxides are pollutant, they cannot be allowed to escape into the atmosphere. The NOx storage catalytic converter absorbs and stores the nitrogen oxides formed during stratified-charge engine operation. To enable it to do this, it is coated on the inside with a layer of barium carbonate. The remaining exhaust gases pass through the storage catalytic converter unchanged, or are converted into harmless water and carbon dioxide. The storage capacity of the barium carbonate layer is limited, however. If the nitrogen oxide sensor at the output of the storage catalytic converter measures an increase in the concentration of nitrogen oxide, the storage catalytic converter needs to be cleansed. The method applied makes use of the fact that in the engine's homogeneous mode, the NOx storage catalytic converter acts as a 3-way catalytic converter in a similar way to the first catalytic converter fitted near the engine. The engine therefore briefly switches into its homogeneous operating mode, regardless of current power requirements. Now other combustion products appear. These react with the nitrogen oxides, converting them into non-toxic nitrogen gas, which is then released into the atmosphere. The storage catalytic converter is of course also cleansed every time the engine switches into homogeneous mode to provide increased power. The storage catalytic converter can store most efficiently only in a narrow temperature range, between 250 and 450 degrees Celsius. This means that it needs to be warmed up quickly after the engine has been started from cold. Once the engine has warmed up, on the other hand, it must be protected against overheating, as it would become damaged above a temperature of 760 degrees Celsius. Therefore, the exhaust temperatures must be measured at the catalytic converter's input and monitored by the control module. The control module influences the exhaust temperatures by directing the exhaust gas either through the bypass pipe only or through both pipes. In which exhaust pipe do you think the exhaust gases cool down more? The exhaust gases cool down more in the cooling pipe. This pipe's larger flow area means that the gases flow more slowly than in the bypass pipe, so there's more time to dissipate heat to the walls of the pipe. The cooling pipe is also longer, which again helps to increase flow time. Following a cold start, the control module shuts the exhaust flap. The exhaust gases flow quickly through the bypass pipe so that the storage catalytic converter can quickly heat up to its optimum temperature. Once the exhaust gases reaching the storage catalytic converter are sufficiently hot, the control module opens the exhaust flap. Some of the exhaust gas now cools down in the cooling pipe, enabling the storage catalytic converter to maintain its optimum temperature. In this chapter you have learned about the exhaust system of the M271DE engine. Apart from a 3-way catalytic converter, the system also features a nitrogen oxide storage catalytic converter. Various sensors register the exhaust gas data, including 2 oxygen sensors, one located upstream and one downstream from the 3-way catalytic converter, as well as a temperature sensor at the input and a nitrogen oxide sensor at the output of the storage catalytic converter. The oxygen sensor upstream of the 3-way catalytic converter is a broadband sensor which is able to measure the residual oxygen content even of lean mixtures. The oxygen sensor located downstream from the three-way catalytic converter, on the other hand, is a two-point sensor, also known as a lambda probe. The NOx storage catalytic converter uses a barium carbonate coating to trap the nitrogen oxides which are formed unavoidably during operation in stratified charge mode. Once the storage layer is saturated, the engine briefly switches into homogeneous mode so that the nitrogen oxides can be broken down. Maintaining the correct operating temperature is crucial to storage efficiency. For this reason, the exhaust system features a temperature control consisting of two different exhaust pipes and an exhaust flap. The chapter concluded by mentioning the harmful effect of any sulfur contained in the fuel used, which makes the use of super unleaded fuel necessary.